Every system is made up of pieces, and the hardest question in architecture is often, where do you draw the lines between those pieces? Two principles, cohesion and coupling, give you a precise practical way to answer that question. This video teaches you what they mean, how they pull against each other, and how to use them together to make better design decisions. When a code base grows, the natural instinct is to break it into smaller pieces. But splitting in the wrong place often makes things worse, not better. You end up with modules that are thin and unfocused, yet deeply dependent on each other. Cohesion and coupling are the two lenses architects use to judge whether a split was actually an improvement or just a rearrangement of the same problem. Think about how a kitchen is organized. Everything you need to prepare a meal lives in one room, grouped by purpose. That is cohesion. And the kitchen works independently. It does not need to borrow things from every other room to do its job. That is loose coupling. When a room does need something from another, there is a single clean handoff point, not a tangle of dependencies running through walls. Here is what the target looks like structurally. Each module owns all the logic and data relevant to its single responsibility, that is high cohesion. The arrows between modules are narrow and well-defined API calls, not direct database reads or shared internal state, that is loose coupling. When the order module needs to confirm payment, it calls a clean interface on the payment module and nothing more. The internals of each module are its own business. Follow a single request through the system. The user places an order, and the order module handles all the business rules that belong to it. When it needs payment processed, it calls the payment module through a well-defined interface. It does not reach into payment internals. The payment module does its job and returns a clean result. The same pattern repeats for inventory. Each module is responsible for exactly one thing, and handoffs happen at explicit narrow boundaries. The contrast is stark. When cohesion is low and coupling is tight, a change in one place forces changes in several others, teams step on each other, and testing requires the whole system running at once. The opposite configuration, high cohesion inside each module and loose coupling between them, means changes stay contained, teams move independently, and you can test a module by itself. Note the warning: splitting too aggressively without grouping related logic raises coupling without gaining focus, leaving you worse off than before. Use these two principles as a test, not just a goal. When you propose a new split, ask two questions. Does each resulting module have a single clear reason to change? And does the split reduce or increase the calls between modules? If splitting something into two pieces means they now call each other constantly, you have drawn the boundary in the wrong place. The right boundary is one where cohesion inside goes up and coupling outside goes down at the same time. Two principles, used together, define healthy boundaries. High cohesion keeps each module focused and self-contained. Loose coupling keeps the connections between modules minimal and stable. Neither principle alone is enough. A system can be tightly focused yet still deeply entangled. When you evaluate any design decision, check both. Does this split make each piece more coherent, and does it reduce the dependencies between pieces? If the answer to both is yes, you have found the right boundary.